The disk method we learned earlier did not involve any empty space within the rotating object. However, when rotating an arbitrary region around a fixed axis, a different approach is needed if there is empty space created in the resulting solid. The graphs of linear and quadratic functions intersect at the origin and 1, 1. The shaded area between these two graphs is then rotated around the x-axis, while the outer part forms a cone. There is an empty space inside. Let the distance from the axis of rotation to the outer edge of the cone be r, and the distance to the outer edge of the empty space be r. The rotated region is created by the difference, r minus r. The area at an arbitrary x can be expressed as the difference in the areas of two circles. Do not confuse this area with the square of the difference of two radii. If we assume a shape where countless thin disks are stacked together, we can use integration. For convenience, we move the pi outside the integral sign, and the integrand represents the area difference of two circles as a function of x. After simplifying the expression and evaluating the definite integral over the interval, we can determine the volume of the desired solid, 2 pi over 15. Let's clarify this part again. At any x, considering the distance from the axis of rotation to the outer edge of the solid as r and to the inner edge as r, the formula for this area of the disk is defined, and we integrate this over the specified interval along the x-axis. Let's consider the following example. There is an area enclosed by the exponential function for x values between 0 and 3. This region is colored and check the coordinates of vertices. When this region is rotated around the y-axis, a resulting solid is formed, revealing an empty space within. Since there is no empty space in the lower part, the disk method can be directly applied. Assuming the distance from an arbitrary point on the y-axis to the outer edge of the solid is denoted as r, r equals 3 in this case. Thus, in the context of integration, the integrand becomes the square of 3. Calculating, we find that the volume for this portion is 36 pi. It's about 113.097. For the upper part where the empty space occurs, we employ the washer method. Let r be the distance from an arbitrary point on the y-axis to the outer edge of the solid, and let r be the distance from the same point to the outer edge of the empty space, where r is a transformation of the given function for x. Converting the given exponential function into an expression for x, it results in a logarithmic function with a base of 3. This becomes the function of r with respect to y. The integration interval is from y equals 4 to y equals 30. Substituting the integrand into the integral and calculating, we get approximately 299.629. Since we have two distinct parts for the solid, each with its own volume, by summing these volumes, we can determine the total volume of the solid. See you next time.